Now I'd like to finish up our Chapter 10 slides here and start off a little bit with logic and conditionals. And so some of the things that you should be able to do with logic and conditionals is just to be able to create simple and nested statements in Excel to produce conditional results. And so this is kind of that if-then structure, talking about, so if something happens in a cell, what do you want it to output if it's true, or what do you want to output if it's false? For a simple if statement or simple logical statement. Then you can also nest those statements depending on what happens. If something is true, you can add another formula in, or another if statement in the true, or you can add a second if statement in the false statement, depending on what type of results you're looking at to get out of your Excel spreadsheet. You should also be able to generate compound logic to develop complex conditions. And in this case, it means adding ors and ands to different conditions. So if you've got a selection of 3 things that it could be pulled from, you're going to know that you're going to need that or statement. And lastly, to predict the outcome of a conditional statement based on what is written, being able to predict that and know what that outcome should be of that conditional statement out of, say, an Excel spreadsheet, and tell me what the output is. So your conditional statements in MATLAB are really based on an algorithm. And so that algorithmic diamond shape is a question, essentially. And so that question is in a true or false, or a yes or no, or a 1 or 0, if you're talking about coding response. And so there are only 2 answers to this question. And so if the question is true, then we're going to do something, or if the question is false, then we're going to do something. And so you see here, so if question 1 is true, we're going to go in this direction, or if it's false, we're going to go in another direction. And so that's kind of how we write our statements. And so for if statements, our syntax of an if statement has 3 parts to it. We start with our equal sign for our formula, add in our if for our built-in function, and then start with our parentheses. And in this first part, it is the condition that we're testing, that condition that needs to be met. And then the second part of the syntax, so after a comma, this is going to be what happens if the condition is satisfied, or if that true statement, value if true. Then lastly, the third part of this is what happens if the condition is not satisfied, or the value if it's false. And so this could be outputting something in the form of a word. It could be outputting a numeric value. It could be outputting a blank cell. Like I said earlier, it could mean nesting a second if statement in this, if you have a second condition that needs to be met if it's true. So any text in an if statement must be in quotes, and really that stands for all Excel. If you have text of any kind that is going into a formula, that formula text needs to have these quotations around it in order for the text to display out in the cell later properly. And so, like I said earlier with our example, if you have, in our if error example, we have this double quotation marks, and that is going to indicate a blank cell. And so here in this simple if statement that we have at the bottom of the screen, equals if, then our condition that we're testing is B5 greater than 10. And if it is true, we're going to output the word higher, noting that higher is in our quotations. And if it's not true, we're going to output this blank cell, or our cell is going to remain blank with nothing in it. Then there are relational operators. Like I said, when you start getting into those more complex if statements, you're going to use your greater than, less than, greater than or equal to, less than or equal to, and not equal to as your relational operators. But you can also have conditional statements where they are set to work off of each other. And so conditional statements in MATLAB work a little bit differently in their construction, because you can nest if statements within each other, or use an if-else statement to indicate that second question on a false. In Excel, we don't necessarily have that leisure, and so we've got to find different ways of doing this. So we could have a set of simplified nested if statements, and so that ifs built-in function is going to have you build paired values based on different conditions. And so we're only looking at what outputs if it's true. We don't ever designate what happens if it's false. So this is that if-else, if-else, if-else type logic. So where we start with our first condition to be met, and then what happens if it's satisfied. Moving on to what is the condition to be met for our second condition, and what happens if it's satisfied. Meaning that this is always in the false portion of your notation. And so you're going to always work in pairs of two in this type of statement. Our logical operators, so when we really get into more complex conditionals, you're going to use your and, your or, and your not. So an and returns true if all of the statements within the and built-in function are true. It returns a false if at least one of the statements is false. In the or logical operators, you're going to return true if at least one of them is true, and it's going to return a false if all of them are false. And then your not logic just inverts the logic within your statement. And then lastly, there are some things that we can use in data lookups, lookup and data validation, that is very useful in Excel. It allows you to take really large spreadsheets of data and look up specific data based on a criteria of some sort. So this is kind of using that logic from our conditional statements and using that to really look up values. And so that lookup function is used to merge data given in two tables with at least one common field. And usually in the case of this, is a user is going to specify, say, a part number, and you are going to look up data referring to that part number in another table. Or you are going to look up a name and then pull out information related to that name out of another table. And so you need to know how to use that VLOOKUP statement or HLOOKUP statement in order to look up that information in that second table. You also need to be able to predict the output if given a lookup statement, so being able to read the lookup statement and know what it's looking for. And then lastly, create a validation protocol for data. Data validation becomes very efficient when you've got very large spreadsheets and you've got to limit some things down, or you want to restrict a user to only pulling from a select values instead of inputting something where they could input it incorrectly. And so our VLOOKUP function syntax comes in this form. So we are looking up a value. So we have our equals VLOOKUP as our function name. And then we are looking up value B5 within a second table. So this, whatever we're looking up is somewhere else, and it is not included in our table reference. So B5 is the cell to look at that uniquely identifies the data. And uniquely is the key part to that, because if, say, you are looking up the name John, and you've got 14 Johns in a list, you need to be able to uniquely identify which John you are trying to look up. And then also, that table that we are looking up into is going to be in a separate table. So in this case, we are looking in a completely different sheet from the one that we are currently in, and looking up cells A1, and using our absolute cell referencing here to indicate that it is only strictly an A1 through E6. And then we are looking up from column 5 in this table. So column 5 would correspond to A, B, C, D, E, saying that out of column E, which is our 5th column, is where our data can be found that corresponds to this cell B5. And then lastly, we want this false, and the false just indicates that we want an exact match to what is located in cell B5. If we don't have that exact match, it is going to report out an error usually on your VLOOKUP statement. And then lastly, these are just some conditional formatting. You'll be using that a little bit in some of your assignments. So some of the things that you should be able to do with conditional formatting is actually conditional formatting to facilitate data analysis, whether that means highlighting specific cells or creating a font that is bold and colored to have those cells pop out at you. Also using conditional formatting to apply multiple rules to create compound logic analysis in your spreadsheets. Just saying, like, if you were trying to separate and color code cells based on, say, a grade, and you have grade ranges, how do we apply multiple rules for things to show up differently? And then lastly, sorting and filtering in Excel. These are some key features when you've really got a lot of data to get through and you need to sort to find things very quickly or filter out things based on values or names. And so you can use Excel to sort data with multiple levels of sorting. And so that means you can reorient your levels of sorting as well to help you sort through. So if you've got a spreadsheet with 600 different columns, you may want to sort first on last name, then first name, then something else within your spreadsheet, or a part number and a location of where that part is produced. And so you want to sort things accordingly based on specific criteria. You can also use Excel to filter data based on specific criteria. So if you only wanted to look at data that was manufactured at a specific location, you can limit your spreadsheet to only show that data. And then also using a subtotal function to analyze filtered data, understanding how to use all of those different functions. So that's kind of the extent of what we'll be using for Excel. We'll hopefully use this in a couple different applications through assignments and such.